Hello and welcome to Easy Maths. This is the second part of this lessons on optimization. It is also the very last lesson of the topic. We've had a series of lessons on linear programming, and therefore let's go straight to the question that we are supposed to attempt. We know that someone has to transport 450 bags of cement and 360 iron sheets to a construction site. He has two vehicles at his disposal. A lorry can carry 90 bags of cement and 30 iron sheets per trip. We have a pickup. He can carry 45 bags of cement and 60 iron sheets per trip. Each vehicle makes at least one trip. If it profits him 900 shillings per trip for the lorry and 600 shillings per trip for the pickup. If X and Y represent the lorries and pickups respectively, write down two inequalities in X and Y apart from X is greater than or equal to 1 and Y is greater than or equal to 1. Again, represent the information graphically. If the contractor has to maximize profits, find the number of trips for each vehicle and the maximum profit. Let's begin with A. I have summarized this information in form of a table and I hope you find this helpful. We have the items to be varied, that is cement and iron sheets. We have the vehicles that will carry that, the lorry and pickup. A lorry can carry 90 bags and 30 iron sheets. Pickup can carry 45 bags and 60 iron sheets. And therefore the total that should be carried is 450 bags of cement and 360 iron sheets. So we can already see the inequalities here. And these are how they're going to be. We're going to let X be the number of lorry trips and Y to be the number of pickup trips. And these X and Y here, the trips of lorries and pickups respectively. And therefore, regarding the cement to be varied, we can actually write it this way: X times 90. The reason is we have X trips by the lorry, each carrying 90, and Y trips by the pickup, each having 45. Should exhaust the total amount of cement to be carried, which is 450 bags, which simplifies to that kind of an inequality, and it's 2x plus y is greater than or equal to 10. Regarding the iron sheets, we say the same thing. We're going to say x times 30, that is the number of trips by the lorry, times the total amount that it can carry in a single trip, plus y times 60, which is the total number of trips by the pickup, and total amount that it can carry, number of iron sheets per trip, should exhaust all the iron sheets that are there to be varied, which is 360, giving us that inequality, which simplifies to x plus 2y is greater than or equal to 12. And therefore we've written the two inequalities. We are done with part A. We go to B. We are told to represent the information graphically. We'll need to draw lines for this, and please allow me not to go to the whole idea of how to draw this line, the line for this inequality and line for the other inequality, or even for this inequality or of this one. I hope you should be able to do that. So I bypassed that. And so we have that. Our business here is to get the wanted region. And so let's begin this way. For the inequality 2x plus y is greater than or equal to 10, we use the origin O, which is 0, 0 for both x and y, and this is the point here, x and y are both 0. We put 0 on the inequality here, and that reduces to 0 is greater than or equal to 10, and this does not make mathematical sense, and therefore we're going to conclude that the origin, the one we picked, is the unwanted region. So as far as the 2x plus y is equals to 10 line, this line here, as far as that line is concerned, we don't want the origin side. We want the other side. Moving on to x plus 2y is greater than or equal to 12, we again test using the origin, the point O, 0, 0 for both x and y. Putting x and y to be 0 in this inequality, we're going to have 0 is greater than or equal to 12. This again doesn't make mathematical sense, and therefore the origin, as far as this other line is concerned, is in the unwanted region, and therefore we don't want it. We want the other. Again, for these two, x greater than 1, greater than or equal to 1, y is greater than or equal to 1, we obviously shade as I've brought that shading there. Now we have the region R that has been left out there. It's an open region. I found this question particularly interesting because part C we are taught to maximize, and it looks like we are minimizing here. And I'm going to have a comment about that. And let me say this. To maximize profit, we minimize trips. So this question must just, it is talking about maximizing. It has an aspect of minimizing. All right. And that is part C. We look for the number of trips for each vehicle. And so let's begin it this way. We have a subjective function 900x plus 600y is equal to k. That is obtained from this line here. If it profits him 900 shillings per trip for the lorry and 600 shillings per trip for the pickup, then we have this kind of function where this is the profit that the person makes, but he makes that profit by minimizing the number of trips. The comment I was making at the point C in the beginning there, I said this question is particularly interesting. Now, all questions that have to do with minimizing, they don't have to be closed. I think so. And that's why we have a region R which is an open region, and we just want to be closest to the origin as possible, maybe, or something like that. But, well, I know that for this particular question, it's not going to turn out that particular way. But maybe I should say that it's not wrong when we are minimizing and the region is an open region. So I'm trying to say that's not a problem. It should be a problem if we are maximizing and it's an open region. Let me say that we have 3 points, this point 1 1 and 8 over 3, 14 over 3 and 10 1, which we are going to consider to minimize. Let me say to maximize the profit. And the point 10 1 gives us the highest profits. Therefore, according to Roman 2, the maximum profit will be given by 10 lorry trips and 1 pickup trips, which is going to be 9600. If you consider this value, it's going to be a smaller number, and this is also going to be a smaller number. And therefore, our answer will be given by this particular point. 10 lorry trips and 1 pickup trips to maximize profit, which will also minimize the number of trips by the pickup. Sorry, by both pickup and the lorry. So please like, share, and subscribe. I will always appreciate. This brings me to the end of a series of lessons on all topics in Form 4. If you like, please, I would like to share. If you are interested in any of this, I'll be willing to share even the PowerPoint lessons, which are probably much better than the videos.